Hi guys, this is Jim Martinez with the 8th Grade Science channel. This is the last video of the three for the plate tectonics unit that we're looking into. Remember, this is the earliest theory that we had before the plate tectonics theory. This is the continental drift. These are all the evidence. This is Alfred Wagner, right? And if you flip the page, you got your Pangea, where you put your continents together and you color them. This is where we start. This is the ticks that we're going to be focusing on today. Ticks 8.9 letter B, and this is to relate the theory of plate tectonics to the formation of crustal features. Make sure you have copy this thing after this page. Make sure you copy all this down. These are all the items that we are going to be looking into for this tick, right? I made two videos previously about the density and about convection currents. So we're gonna start with earth layers. We gotta turn this page or your composition book sideways so we can look at this. Now, I have covered this before when you have the two main parts of the earth, which is the mantle and the core. And then the mantle is subdivided into the crust of the earth, the lithosphere, the asthenosphere, and the mesosphere. And then the core is subdivided into the outer core and the inner core, right? So make sure you know those. The most important one is the mantle and the crust of the earth, because those are going to be playing a very important role about the convection currents. But today we're going to be focusing on this one. These are the convection currents. So let me look closer, and you can pause the video and copy all the notes that you need for this thing. We're going to start with the inner core and the outer core. This is where all the energy is coming from. Remember, we have radioactive material inside the core of the planet where, as it's decaying, it's releasing a lot of energy, a lot of heat. So therefore, in the mantle, the magma that is closer to the core of the planet is the one getting the most heat. And as the magma gets closer to the core and it gets hot, remember, it loses density and it rises to the top, right? It floats. And as it goes to the top, it hits the crust of the earth. This is the crust of the earth, and it moves to the sides. And as it moves, it will move the continent along with it. It will move the crust along with it. All right. So this, when you have an example of this area of the crust of the earth that is moving, these are the plates. All right. The crust of the earth is divided in different plates. So when the plates move away from each other, like the way it's happening right here, we call those divergent boundaries. Right. Remember, this area, it all belongs to the lithosphere, which is a little section on the top of the mantle of the earth, right? At some point, when the convection currents move away, in some areas they separate, right? The magma separates, but in another area, the magma, they collide and it sinks. This is the area when the magma cools down. Remember, it takes millions of years for this movement to occur. And as the magma cools down, density increases, and then the magma sinks to the bottom, where it's going to be getting hot again and doing the whole thing. Okay? In this area where the two plates collide, because you can see the currents coming this way and this currents coming this way, here they're going to be colliding. We call those convergent boundaries. We're going to be explaining more about those later on. But this is a deep trench, and this area where one of the sections of the plate is sinking, we call that the subduction zone. All right? So looking at this way, or this section, it will be the same thing. We have a convergent boundary here because we can see the two plates colliding as they move closer to each other. One of them, the one that is denser, is gonna sink, and as it sinks, it's gonna form this deep trench. right there. And then we call this area, or the section of the plate that is sinking, the subduction zone. All right, so make sure you have all those titles. And now we're gonna be explaining what happens at point A, B, C, and D. So ready? Here we go. At point A, as you can see, on this side of the flip, you're gonna be putting letter A, and then you're gonna be writing what is happening there, right? You can pause the video at any time, remember, but I am gonna be explaining. At point A, magma is cold. Well, it's not really cold, right? Because it's magma, but it is at the coldest that it's gonna be getting. As it cools down, or as it's cold, it becomes denser, it becomes heavier, and of course, due to gravity, it's gonna be sinking, right? Pushed by gravity. That is what's happening here at point A, because he already traveled all this area. Magma has traveled, it's taken millions of years to move from here to here. So now the magma here is cold, is dense, is heavy, so therefore gravity is gonna push him down. Now let's take a look at what's happening at point B. So make sure you flip this and write down letter B and put that magma moves towards C, right? And of course, it's gonna be taking millions of years also for that to happen. And as it does, it's gonna start getting hotter, because remember, now magma is close to the core where the heat source for our planet is happening. So if the heat is coming from the core, the magma, as it gets closer to this area, is gonna start getting hot and hot and hot, right? And as it becomes hotter, it's gonna be, once again, losing density, and it's gonna become lighter. Those molecules are gonna be separating, and then as it loses density, it's gonna start floating again. So that is the cycle of the convection currents. So that is what's happening at point B. Right? Let's take a look at point C. In point C, we have magma is hot, and it lost density. So it will be floating towards point D, or letter D, again. So that is exactly what's happening here at point C. By this time, magma is already very hot, right? So physics is gonna do its thing, which is gonna allow this magma to start floating again. Remember, all this process takes millions of years. All right, let's take a look at the last one. Last one is letter D. So magma is gonna be hitting the hard lithosphere, or the crust, right? The crust of the earth. When it goes up, it's gonna spread to the sides, and it's gonna be pushing the plates along the way. It moves towards A as it is gonna be cooling down on its way. So once again, make sure you pause the video, write all this information, but this is what's happening here. Once again, as the magma goes up, here is the, I guess we can say, the hard part. Remember, this is kind of like semi-liquid type of material, but on the top, the crust of the earth is solid, right? There is no liquid, there is solid. So as the magma hits the plates over here on the top and it spreads, as it moves the plates along with them, right? This is why the plates move. This is what Alfred Wegener didn't understand, okay? And as it moves from point D towards point A, right, it's gonna start getting colder and colder, and it's gonna become denser and denser, a lot heavier, and then eventually it's gonna be sinking, completing the cycle of the convection currents. Any questions? So once again, let me see if I can put the whole thing there so you can pause it and write it down. Okay, let me keep on going. These are the plates. Right here we have all the different plates. You don't have to remember that the names are there: the Atlantic plate, the Oceanic plate, the Nazca plates. the Southern American plates. You don't have to remember all the names of the plate, but just know that at some points the plates are separating, as you can see right here, how the plates, the arrows are pointing in opposite directions. That means the plates are separating. Okay, at some points, if you look over here, if this plate is moving this way, look what's happening to this Nazca and this other, I think it's called the Antarctic plate, how these ones are moving towards this one over here. So what happens here, this is the collision where the two plates are going to be colliding, right? At some points they separate, and at another point they collide. Like right here, they're colliding. But the edge of these two plates is right on the edge of the continents. So that's why we can't see the line like these ones over here that are separating. Okay. Remember, there is two types of plates. There is continental plates. Those are the ones that carry the continents. And there's also oceanic plates. And those are the ones that carry an ocean. All right. I believe we saw that here. This is an ocean, so therefore it's called an oceanic plate. This one is a continent, so therefore it's called a continental plate, right? All right, so just know those things. Here is the key where you have the convergent boundaries. We have also divergent boundaries, and then we have transform faults. But we don't have to worry about those yet. Now, following along the why and the how those plates are moving, we have seen this on the beaker on a previous video, where we can see this is the heat source, right? This will be the core of the planet where the heat is coming from, and this will be the magma that is getting hot, that is going up, and it's moving away. And notice how these wood blocks that represent the crust of the earth, they separate as this movement happens. All right. At some point, remember, this water is going to cool down and it's going to sink, and it's going to make those convection currents. So all you have to do here is write down that this is the colder area and this is the hottest area. The hottest area is going to be going up. The coldest area is going to be sinking. And this represents the crust of the earth. Likewise over here, obviously this will be, I guess, an oceanic plate, and this will be a continental plate. It's the same thing. The hottest section will be here, the colder region will be here, and this is how these two plates that are colliding, you can see how they're colliding right here. One of them sinks, but this section right here is the two plates moving apart. These are called divergent boundaries. Okay, that can be seen better on this one over here. Okay, make sure you tape this, make sure you cut them, tape them the way I did right here. And make sure you add these little arrows. We can see here how the magma goes up and it separates. This creates these two oceanic plates to move away from each other. Okay. Look at this area right here. You see these arrows coming, and then this one's coming towards each other where they collide. Well, when these two plates collide, they carry continents on top of them. So this is where we have a convergent boundary. We can see these arrows. Make sure you add those little arrows, are very important. This is the colder section of the magma that is going to be sinking. This is the hottest area of the magma that is going to be going up. All right. But remember, as the magma moves, the continents move along with them. And then the last one that we have is this one. Now here we have two divergent boundaries as those two plates are moving away from each other. And here we have convergent boundaries where we have these two plates that are colliding because they're moving against each other. All right. This is a deep trench. This is a mid-ocean ridge, but we're going to cover them later. This is a subduction zone right here. These are convergent boundaries too. All right. There is no notes on that one. So just to recap, if we fix our composition book, this is what we're going to cover on a different class, right? These are the evidence of the plate tectonics theory. And there is, I believe, several ones. There's evidence number 1, 2, 3, and then evidence number 4, right? This one is sideways. Okay, then we're gonna be looking at the plate boundaries and then all the features from each of those types of boundaries. Okay, so that's all. Make sure you have this done. Make sure you copy all the little notes on these ones. And make sure you copy everything that is happening inside the convection currents on this flip side. That's all for today. Bye-bye.